So, good afternoon. Today is March the 19th, and I am here to talk to you today about what we call centripetal force. Now, if you're driving along a road in a straight line, okay, you have at a constant speed, you also have a constant velocity, because remember, velocity has both a magnitude and a direction. And so if you're traveling in a straight line, your direction is constant, and if your speed is constant as well, then you have a constant velocity. Make sense? Now, if that's the case, then if you change either one of those two things, either the magnitude or the direction of the velocity, you end up with a change in the velocity. Right? So you can do this in one of three ways. You can either step on the gas and increase your speed, step on the brake and decrease your speed, or you could turn the wheel. And if you turn the wheel, you've changed the direction that your car is moving in. That change in direction is what we consider to be a change in velocity. Now, any change in a velocity is called an acceleration. And as we know from Newton's second law, any acceleration is caused by a force. Now, that's what brings us to section 9.3, which is entitled centripetal force. Any force that causes an object to travel in a circular path is called a centripetal force. The word centripetal means center seeking, okay? Meaning that we're going in circles, right? Just like the words just spun around there on the page. Now, a centripetal force obviously is something that causes a centripetal acceleration, but more importantly than that, it's any force that causes an object to follow a circular path. Now, a couple of examples of that. In class the other day, I took a washer and tied it to a string, and I swung the string over my head, remember? All right, well, the string in that case was providing a centripetal force, but the force wasn't some magical new thing. It was really just the tension that exists between my hand and the washer, the tension in the string between my hand and the washer. So tension is one thing that can cause a centripetal force. Another example would be the force of gravity for moons orbiting planets, or perhaps planets orbiting stars, or even galaxies orbiting the centers of the universe. The force that keeps them moving in their circular paths, their revolutions around whatever the center is the force of gravity. And so again, in this case, the centripetal force is not some new different kind of force. It's actually something we're already quite familiar with. The force of gravity provides the centripetal force. The last example is the one that you see in the picture here on your screen, right? When an automobile drives around a circular path or goes around a corner, right? In this case, what causes the car to actually curve and go in that circular path is the friction between the tires and the road. If there was no friction, right, for example, let's say it wasn't asphalt but rather pure ice, the car would simply keep going straight forward and wouldn't turn at all. Right? Hopefully none of you have experienced that, but I know that a couple of you may have. It's the friction between the tires and the road that provides the centripetal force. So in all three of these examples, the centripetal force is not something new or exciting or different. It's the tension in the string provides centripetal force, or gravity provides centripetal force, or the force of friction between the tires and the road that provides a centripetal force. All right, so that concludes my lesson on section 9.3. Your homework for today is to do the worksheet section 9.3, which is also embedded on this page in the portal. Okay. Stay safe, be good, and may the force be with you.